Hello! In this video we'll talk about functional dependencies, which is an important concept in relational schema design theory and a tool for analysis. Definition: denoted by X determines Y between two sets of attributes X and Y that are subsets of R, specifies a constraint on the possible tuples that can form a relation state R of R. The constraint is that for any two tuples T1 and T2 in R that have T1 of X equals to T2 of X, they must also have T1 of Y equals to T2 of Y. A functional dependency is a property of the semantics or meaning of the attributes. Well, let's see some examples for the same relation. This relation has the attribute ID, first name, last name, age, and phone, and 6 tuples with some values there. So let's analyze the following arbitrary cases in order to check if they are functional dependencies or not. First name determines last name. Well, with the help of the definition, we're going to find at least 2 instances of first name with the same values. This is T1 of X equal to T2 of X. We don't look for different tuple values for X because they check the definition. We just look for the repeated X values. So here we have T1, the tuple surrounded by a red frame, and T2, the tuple surrounded by the blue one, where the X value is penny in both cases and the Y value is rows on T1 and Powell on T2. So, as Y values are different for same X values, this is not a functional dependency. Case 2. Does phone determines last name? Here we don't have 2 instances of phone with same values, so this doesn't violate the definition of functional dependency. In this case, we can say that phone uniquely determines last name, and in conclusion, second case is a functional dependency. The same thing happens for third case. Phone uniquely determines age, so it's also a functional dependency. Case 4. Does age determines last name? Here we have 3 tuples with same value for age. I choose the first 2 tuples T1 and T2 where the X value is 36 in both cases and the Y value is Rose on T1 and Marshall on T2. It is sufficient to demonstrate a single counterexample like this to disprove functional dependency. On case 5, we have X set with ID and age attributes as its members, and on the other side, first name and last name attributes as Y members. So, does ID and age determines first name and last name? We have to find 2 tuples with same X value, this is same ID and age simultaneously, and you can see here that there aren't such tuples by looking at ID values. They are not same, so ID age values combination is not repeated. We can affirm that case 5 is a functional dependency. And finally, for the same reason, case 6 is also a functional dependency, where X member is ID and Y member are first name and last name. You can check there aren't any X values repeated. And thanks for watching. Give me a like if you enjoyed the video, and if you want to support my work, just subscribe to my channel.